Figure shows 8051 architecture. The 8051 architecture consists of three specific features. These specific features: 8-bit CPU with register A, the accumulator, and B, 16-bit program counter and data pointer, 8-bit program status word, 8-bit stack pointer, internal ROM of 4 kilobytes, internal RAM of 128 bytes. Now the internal RAM is divided into 4 register banks, each containing 8 registers, 16 bytes which may be addressed at the bit level, 80 bytes of general purpose data memory. 32 input or output pins arranged as 4 8-bit ports P0 to P3, two 16-bit timers and counters, that is T0 and T1, full duplex serial data receiver cum transmitter, that is SBUF register, control registers TCON, TMOD, SCON, PCON, IP and IE. TCON is timer control register, TMOD is timer mode register, SCON is serial communication control register, PCON is power control register, IP is interrupt priority register, and IE is interrupt enable register. There are 2 external and 3 internal interrupt sources, oscillator and clock circuits. 8051 is a 40-pin IC. So on this slide you can see the 40-pin IC diagram of 8051. You will find pin number 1 to pin number 8 forms port 1. Pin number 9 is the external reset pin. Pin number 10 to pin number 17 is port P3 with additional functions also. Pin number 18 and 19 are used as XTL2 and XTL1 for connecting crystal oscillator. Pin number 20 is ground. Pin number 21 to pin number 28 is port 2. Pin number 29, 30 and 31 are used during memory access. Pin number 32 to 39 is port 0 and pin number 40 is VCC. Let us see the pin description in detail. Pin number 40, as I said, it supplies supply voltage to the chip. The voltage source is 5 volt. Pin number 20 is the ground pin. Pin number 19 and 18, that is XTL1 and XTL2, are used for providing the external clock. RST pin is pin number 9, that is reset pin, and it is active high. Whenever a high pulse is applied, the microcontroller will be reset and all the values in the registers will be lost. Pin number 31 is EA bar, that is external access pin, which is connected to ground to indicate that the code is stored in an external ROM. Usually in 8051, EA bar pin is connected to VCC. PSEN bar, pin number 29, program store enable. It is an output pin which is connected to the output enable pin of a ROM. Pin number 30, that is ALE, address latch enable. It is an output pin and it is active high. Port 0 provides both address and data. So this pin is used for demultiplexing the address and the data. Then we have the IO port pins. There are 4 ports, P0, P1, P2 and P3. Each port uses 8 pins and all IO pins are bidirectional. This is the programming model of 8051. When we are telling programming model, it implies what are the registers and which are the memory locations available or available for the programmer for using it during programming. The programming model of 8051 is a collection of 8 and 16-bit registers and 8-bit memory locations. These registers and memory locations can be made to operate using the software instructions. Most of the registers have specific functions. Each register, with the exception of the program counter, has an internal 1-byte address assigned to it. Some of the registers which are marked with an asterisk in the diagram are both bit addressable as well as byte addressable. That is, the entire byte of data of such a register addresses may be read or altered, or individual bits may be read or altered. Software instructions are generally able to specify a register by its address or by its symbolic name or both. Let us concentrate ahead with the programming model. 8051 oscillator and clock. The heart of 8051 microcontroller is the circuitry that is generating the clock pulses so that all internal operations are in sync. Pins XTL1 and XTL2, these are used for connecting to an external resonant network to form an oscillator. So either you can use a crystal oscillator or ceramic resonators can be used over here to provide the clock frequency. Serial data communication needs the frequency of the oscillator because of the requirement that internal counters must divide the basic clock rate to get a standard communication bit per second rate. The oscillator formed by the crystal and capacitors generate a train of pulses at a particular frequency of the crystal. If we consider f as the clock frequency, it establishes the smallest interval of time within the microcontroller called the pulse, which is p time. The smallest interval of time to execute any simple instructions or part of a complex instruction is known as machine cycle. So we can tell one machine cycle is equal to 6t states. Now what is a state? A state is the basic time interval for discrete operations of the microcontroller like fetching an opcode byte, decoding it, executing or writing a data byte. To calculate the time taken for a particular instruction's execution, let us consider the number of cycles as C to be found. The time to execute that instruction is found by multiplying C by 12 and dividing the product by crystal frequency. So the equation is T instruction or the time taken to execute an instruction is equal to C into 12 divided by the crystal frequency. One machine cycle is equal to 2 ALE pulses. The ALE pulse is used as a timing pulse for external memory access when every instruction byte is fetched.